In match problem 6, we have an amusement company that maintains records for each video game in its arcade. C and T and R of T represent the total accumulated costs and revenues in thousands of dollars, and T represents time in years after a particular game has been installed. So we have a marginal cost function, a marginal revenue function, and in part A, we want to find the useful life of the game. And we're defining useful life as when costs equal revenue. So the game has stopped bringing in as much money. We're basically breaking even on it, so we've gotten as much useful life out of this device as we're going to. So we want to find the useful life of the game to the nearest year. In this case, part A doesn't actually require any calculus. So if we want to find when the rate of change of our costs equals the rate of change of our revenue, we can just take these two given functions, set them equal to each other, and then solve for t. So we'll start by dividing both sides by 7.5, which will give us 2 over 15 equals e to the negative 0.5t. Taking the natural log of both sides, natural log and e will cancel each other out, leaving us with just negative 0.5t. And then dividing both sides by negative 0.5 will give us the natural log of 2/15 divided by negative 0.5, or approximately 4 years. So the useful life of this particular arcade machine is going to be 4 years. Now in part B, we want to find the total profit accumulated during the life of the game. So part A didn't actually require any calculus on our part. Part B will. So if we want to find the total profit that this device is going to generate for us, essentially we want to find our profit function evaluated at 4 minus our profit function evaluated at 0. So how much money we made in the 0th year minus, or being subtracted from how much money we made altogether. So we don't have the profit function, but if we could integrate from 0 to 4 a marginal profit function, then we would come up with this result. So we don't have a marginal profit function, but what we do have is a marginal revenue function and a marginal cost function. So we can integrate from 0 to 4 our marginal revenue function minus our marginal cost function dt. So revenue minus cost gives us profit, marginal revenue minus marginal cost gives us marginal profit. So let's also introduce kind of a shortcut here now that we've been doing integration by substitution for a while. The integral of e to the ax dx. So the integral of e to the x would just be e to the x, but now we have e to the some constant multiple times x, is just going to be e to the x over a plus some constant c. Or we could rewrite that as 1 over a, let me go back. That will be e to the ax, so that exponent remains unchanged, divided by a plus some constant c. Or rewriting that just a little bit, we could write it as 1 over a times e to the ax plus c. So given an integral like this, we can apply integration by substitution. So that's fine if you don't want to memorize this shortcut, but it is kind of a relatively easy trick. The integral of e to the 2x, 5x, whatever number is being multiplied by x, is the same as 1 over that number times e to the ax. So we'll take advantage of that here. 7.5 e to the negative 0.5t will become 7.5 over negative 0.5 e to the negative 0.5t. So we could have gone through the process of substitution, integrated that, we would get to this exact same result. Minus the integral of 1 will be t. And then we want to evaluate this from t equals 0 to t equals 4. So 7.5 divided by negative 0.5 is going to give us negative 15. So this will be negative 15 e to the negative 0.5 times 4 minus negative 15 e to the negative 0.5 times 0. So anything to the 0 power is just 1. So we have negative 15 e to the negative 2 I apologize, I'm making more than a few mistakes in this problem. Let's go back a couple steps here. I was leaving out this second term completely. So if we're integrating this expression from t equals 0 to t equals 4, that's going to be negative 15 e to the negative 0.5 times 4 minus 4 minus that same function evaluated at t equals 0, which will be negative 15 e to the negative 0.5 times 0 will just be to the 0 minus 0. And then again, distributing this negative through, that will become plus 15, and then e to the 0, anything to the 0 power is 1. So now we have negative 15 e to the negative 2, so negative 0.5 times 4 is negative 2, minus 4 plus 15 is approximately 8.97. So the total profit is approximately 8.97, where this value is in thousands of dollars. So we could say, or our total profit is $8,970. So that's our total profit we'll earn for this machine over the 4-year useful life.